water.
All right. So, last time we met, we identified the empirical formula from just knowing the grams of the material. Now we're going to learn how to find the empirical formula from percentage information about the nitrogen, hydrogen, or oxygen. Now this might be, oh no, so different. What are we going to do? But it's actually exactly the same thing. Because last time we were given information about the grams of the different elements. And from that information about the grams, we could find the empirical formula. So we can go back to this one and we can remember what we did. So we said we had 0.522 grams of nitrogen, 1.490 grams of oxygen, and we needed the empirical formula. Well, the empirical formula is not the grams ratio, but it's the moles ratio. So we just had to convert this grams of nitrogen to moles, grams of oxygen to moles, and then use those numbers as the empirical formula and make them whole numbers. Well, for this one, it's very similar because when somebody says, hey, I have a substance that's 35% nitrogen, 5.05% hydrogen, and 59.96% oxygen, what they're saying is they're telling you how many grams of the material they have, of the different elements they have, because percentage is in grams. So when you see a question like this, 35% nitrogen can mean 35 grams of nitrogen. And 5.05% oxygen can mean 5.05 grams, hydrogen. And then 59.96 grams or percent oxygen, that can mean grams of oxygen. Because if you had a 100-gram sample, this would be the grams of the different elements that you have in your material. So we have to do the same thing, just convert these grams to moles, and then we can get ourselves an empirical formula, NX, HYOZ. All right. So can you tell me how many moles each one of these is?
Hydrogen is 5 moles.
Good. 5.05 moles.
Nitrogen is 2 moles.
2 because you took nitrogen, which is how many?
14.
All right, so you want moles of nitrogen. So we took 35 grams of nitrogen, and we went from grams of nitrogen to moles of nitrogen, and there's 14 for every 1 mole. So what's 35 divided by 14? Is it 2.5?
2.5.
2.5 moles of nitrogen. Good. Now, 59.96 grams of oxygen. How do I convert that to moles?
$16.
Yeah, 59.96 divided by 16. 3.75 moles of oxygen. Okay. So I can use these moles values here as the X, Y, and Z for this nitrogen, hydrogen, and oxygen. So nitrogen, 2.5, hydrogen, 5.05, and oxygen, 3.75. Now, do you remember how to make these whole numbers, what we had to do?
Times it by the smallest one, which is 2.5.
All right, not times it, but divide it by, right?
Divide it by.
All right, so if we do that, then nitrogen becomes 1. What is hydrogen?
Hydrogen.
5.05 divided by 2.5.
5.05 divided by 2.5. 2.02.
All right, so pretty much 2. What about 3.75? 1.5?
1.5.
All right, so it looks like we have NH2O 1.5. What do we got to do?
Divide it by 1.5.
No, this one's 1 already. You just divide by the smallest when you don't have any of them to be being 1. But now we have to multiply everything by something so that that becomes a whole number, right?
By 2.
Yeah, multiply everything by 2. So N, what?
2.
2. H?
4.
4. O?
3.
3. Very good. That's the empirical formula, N2H4O3. Now, we're going to determine the molecular formula if the molar mass of the compound is 80.06. 80.06. How do we do that? This is not the molecular formula, this is the empirical formula, right?
Right.
So, what's the relationship between the empirical formula and the molecular formula? How do they compare to each other? What's the difference?
The empirical formula, you just divide it by numbers, and then it's basically the same, but just different numbers.
Okay, that's right.
All the values are the same.
To get to the molecular formula, you might have to multiply it by a value. So, how can we find that value? Remember, we have to compare the empirical mass to the molar mass. The empirical mass here can be determined because we have the empirical formula, and the molecular mass, we're told, is 80.06. So, what is our empirical mass? Wait a second, 16 times 3, right? Plus 14 twice, plus 4 for the hydrogen. That's 80 already. So our empirical mass is 80.6 and our molecular mass is 80.6. What does that mean?
The real answer is N2H403.
Yeah, that means that the molecular formula is the same as the empirical formula. Very good.
They're a little different.
What do you mean, the masses?
Yeah.
Yeah, a little different because of our significant figures that we had. Okay. Here's another opportunity. Given the composition analysis of lindane, here's the percent carbon, here's the percent hydrogen, and here's the percent chlorine. What is the empirical formula? Okay. So, to do this one, we can pretend that we have a 100-gram sample. And therefore, we can start with 24.77928 grams of carbon. And we're going to convert that to moles of carbon by using the molar mass of carbon. 1 gram or 1 mole is 12 grams. All right. Do that for carbon. And then we're going to do it for hydrogen, 2.07943. 2.07943 grams of hydrogen. We're going to go to moles of hydrogen. grams of hydrogen down here, moles of hydrogen up here. I like to use more than just one significant figure with the hydrogen. So I use 1.01 or 1.008. So I'm going to put 1.008 and then 1 mole there. Okay, and then for the moles of chlorine, I'm going to start with the grams of chlorine, 73.14129 grams of chlorine, and go from grams of chlorine to moles of chlorine. And 1 mole of chlorine has 35.45 grams of chlorine. All right. Did you do any of those in the calculator?
I'm going to do them in the calculator.
No, I was just wondering if you did. So I did the first one, and I got 2.063. The second one, 2.07943 divided by 1.008, 2.063 also. The third one there, 24.77928 divided by 12, 2.065. All right, what does that tell us?
It's B.
B or D?
B as in boy.
Well, don't I have to take the CXHYCLZ and use those numbers? 2.063, C 2.063, H 2.063, CL 2.065. Then I have to divide them all by what? 2.063, right? And that's going to be CHCl. Each one's going to be 1, right?
It's D.
That's right, D. Very good. Now, here's a follow-up question on that one. If the empirical formula was CHCl and the molar mass is 290.83, what's the molecular formula? What do you think? How do we do this one?
Times it by whatever number.
Times what?
What's the numbers we got?
We got CHCl is our empirical formula. That's what it says right here, CHCl. And the molar mass is 290.8316. So we have the empirical formula and the molecular mass, or the molar mass. Now we need to find the empirical mass and compare it to the molar mass. So can you find the empirical mass for CHCl? Carbon is 12. Hydrogen 1.0.
I got 48 adding them all up.
Okay.
You have to times it by whatever.
Yeah, 48 is the empirical. And the molar mass equals, the molecular mass equals 290.8316. So how do we find what our multiplier is? Do we take the 290.8316 and divide it by 48? Yeah. And now what do we do with that 6? What is that? How does that get us closer to the molecular formula?
It makes you 2 away.
you just have to take the empirical formula, right? Empirical formula, which is CHCl. And to get to the molecular formula, you use the same multiplier. So it must be what? What's the molecular formula?
A.
A, that's right. C6H6Cl6. Okay, very good.